Hi, I'm Patricia,
I'm Pratima.
and we're just gonna go over our lab 4.
So this is our top module. The clock takes in inputs from the switches and it outputs the current time on the display by default. And when the alarm is set and the alarm on input is on, it'll also output a sound at the alarm time. So a brief overview of our top module here. Hours, minutes, and seconds are all they're all initialized to 0, and we have a clock that is about 1 hertz, and every second the clock numbers will increment using this module increment time that's used to add 1 second every second. But if the set alarm input is triggered, then you're in a mode where you can input the time, and when the set alarm input goes down, then the clock will again start counting up from the current time that you set. And you set an alarm the same way that you can set a time. And when the clock reaches the time of the alarm that you set, it'll output an audible sound. So one important module that went into this clock was a save number module. Basically, when this module gets an input that triggers it, whatever number is seen on the switches gets saved, and then once this trigger input goes down, it still outputs the same number. And I use this in order to save hours, minutes, and seconds whenever either the user wanted to set time or when they wanted to set an alarm. So when the correct mode was on, it starts reading the input, and then you use the save number module in order to save hours first, then save minutes second, and then save seconds third. And by putting these all together, once the either the set time mode or the set alarm mode is off, then all the saved numbers are outputted and you can use them in the top module.
Another important section of our code and another important module is the alarm audio, and this basically tells the sound when to go off. So there has to be 2 conditions for it to start going off. So basically equal has to equal 1, which means that the clock time and the alarm time are equal, and then the alarm also has to be on, and then it'll start ringing. And then if the alarm isn't on, then the sound won't ring. But we had to make it so that the alarm would keep ringing past the time that the clock and the alarm were equal. So that's where the else begin is. So like if they're not both on but alarm is on, then it'll continue to ring. When the clock is first opened, it starts at hour 0, which in 12-hour time period would be 12 a.m. And then we use the left switch to toggle between the 12-hour and 24-hour clock. So right now it's in 24 hours. And then when you switch to 12-hour, you can see that it says 12 a.m. As you can tell, there's an A at the end for a.m. In this following clip, you can see that when it's in PM, it also displays a P. And then the following switch turns the set time on, and then the switch after that is the set alarm switch, and then the following switch is the alarm on and off switch. And then switches 10, 9, and 8 control hours, minutes, and seconds. And then finally, the last 6 switches on the FPGA board are to input times, for example, setting the alarm or setting the clock time. And right now, at the time of filming, it was 11:41 p.m. So to set the hour, you flip the hour switch and then you set it to 23 in binary because 23 in the 24-hour clock correlates to 11 p.m. Following this, you flip the switch to set minutes and then you set the minutes to 41 because that's what time it was at the time. And I believe in this specific demo, we left the seconds the same, and then once that was done, you just let the clock start running and it runs as normal. Next is the demonstration for setting the alarm and having it go off. So you toggle the 13th switch, which is the set alarm switch, and then we set it for 11:42 p.m. with 16 seconds, just so that we would have time in between setting it and when the alarm would ring. And then after you set the time that you want the alarm to go off, you have to toggle the alarm on switch so that it'll actually go off. Because if you set the alarm but then don't turn the alarm on, then it won't go off. And then at around 11:42 and then 16 seconds, the alarm should go off. And then you toggle it off, and then the alarm stops once you turn off the alarm. So now to talk about like why we did what we did. We thought that the audio was a more effective way of like triggering an alarm than a light because it's more functional and more realistic to like a real alarm rather than like a flashing LED. As for successes and failures, a success I would say is that we finished everything pretty quickly and in like a timely manner, and we didn't run into like too many huge bumps. But then a failure would be that the alarm sound is a little quiet, so it's a bit hard to hear, and it's also high pitched. So, like, if you're older, you probably wouldn't be able to hear the sound ringing, so that could cause an issue, like functionality wise.
So one thing our clock is pretty successful at is keeping the time accurately. In one of the demos that we filmed, I like compared the time when I set the time and when the video finished, and those times were about 100 seconds apart. And then I looked at the timestamps on the video, and the video was also like 99 to 100 seconds had passed, and I was pretty pleased with how accurate the clock was. And another thing that could be better is the design could be a little bit more robust. The way it is now, if you put in inputs in the wrong order, it might not work exactly as planned. But if we were to have like spent a little bit more time, or like or if we had a longer time to do this assignment, we probably could have tested all those edge cases and made sure that the clock worked as expected, no matter what the inputs were.